Welcome and thank you for joining. Let's take a look at some homework questions from lesson U1 L9. We're working with radical expressions and we're learning how to simplify them. So question number 5a is square root 75 divided by square root of 3. So here we have division of two radicals of the same index. So we can divide because the indices are the same, and we'll rewrite this as the square root of 75 divided by 3. Simplify the expression inside the radical, that's 25, and we can evaluate this. In this case, square root of 25 equals 5. Let's continue with the next question. Again, the index has to be the same for us to be able to divide two radicals. So we have the square root of 16 divided by 2. This time we have the square root of 8. Now, to simplify a radical means to make the radicand the smallest possible. So since we have an index 2, we have to break number 8 down into two factors. And one of them, we prefer to be perfect squares so that we can simplify it. So a perfect square would be 4, which is a factor of 8, and 2. Now, that would be square root of 4, square root of 2, and the square root of 4 equals 2 square root of 2. So this will be the most simplified form of square root of 8. Next, we have square root of 20 divided by square root of 5. So that means we have square root of 20 divided by 5, or square root of 4. The answer is 2. Let's continue with the next one. Square root of 44 divided by square root of 11. So that's square root of 44 over 11. That would be equal to square root of 4, and the answer would equal 2. So next question, we have square root of 2 over square root of 128. So again, the index is the same, index 2, which means we can rewrite this as a single radical, 2 divided by 128. So simplify the fraction. So both divisible by 2 because both even numbers. 128 divided by 2 is 64. So the square root of 1 over 64 would be equal to the square root of 1 over 8 squared, or even better, 1 over 8 to the power of 2. So when the index and the power match, it means that we can take out the base in the radicand. So the answer would be 1 over 8. So we'll continue with the next question. Now remember, you have to do these type of exercises without a calculator. So the index here is 3, which means that we can bring both terms inside the same radicand with index 3. So we have negative 54 over negative 2. Negative 54 divided by negative 2 is positive 27. It's the third root of 27, or the third root of 3 to the power of 3. And since the index is the same as the power, it means that the answer is 3. Now next we have the fourth root of 80 divided by the fourth root of 5, which means that 80 over 5 can come inside the same radicand. So 80 divided by 5 is equal to 16. And the fourth root of 16 equals the fourth root of 2 to the power of 4. And that would make just 2 because the indices will simplify. Sorry about this. Here we go. So next we have the fifth root of 64 divided by the fifth root of 2. Let's see what this will turn into. So we have the fifth root, don't forget the index, of 64 divided by 2. 64 divided by 2 equals 32. Again, fifth root, don't forget. So that would be equal to the fifth root of 2 to the power of 5. So index and power are the same. The answer is simply 2. So now we're going to look at another set of exercises. This time we are expressing as a simple radical each of the terms described. Now, as you can see here, we have variables inside the radicand, inside the radical sign, or in the radicand. And to express these as mixed radicals means that we have to simplify this expression as much as possible. In other words, we have to take out as many factors from the radicand. So first we refer to the index, identify the index, which is 2. So what that means is that we can take out of the radical powers of 2. So we're going to try to write number 25 as an exponential with power of 2, so perfect power of 2. And we're going to try to write x with a power of 2. Now x is already power of 2. Now y is just power of 1, so we cannot simplify that. So therefore, we're going to say that we have in here the square root of 5x to the power of 2 multiplied by the square root of y. The square root of 5x to the power of 2 will bring 5x outside. So because of the powers that are, the power is the same as the index. So we'll have in here 5x. And then we have the square root of y here. Now we have to pause for a second and think, since we have an even root in this case, we want to make sure that the number that we took outside of the even root is a positive one. Now remember, x here inside the radicand can be any real number because when squared, it's still positive. However, when we take it out, we have to make sure that this is a positive number. And if x is any real number, there is a chance of x here being negative as well as 0 and positive. But we have no problem with 0 and positive. So to protect x from being negative, we're going to wear it some absolute value symbol here. And this would be the final answer. Let's continue with the next question. So again, we have to identify the index first. Index is 2. So what that means is that we have to look at every factor inside the radicand and try to express it as a power of 2. So I'm going to draw or write the radical symbol first. And I'm going to try to write each part of the term as a perfect power of 2. So 25 is a perfect power of 2 with base 5. And then we have x to the power of 2. And inside the brackets, we'll have x plus y. So that would be equal to, as you can see, we have 5x, again, to the power of 2. And then we have multiplication by x plus y here. So with an index of 2, then we're going to take that out. So index 2 of 5x to the power of 2. I'm showing all the steps in here. There are steps that we can cut shorter, but I'm just trying to show the entire process of how this is working. And when we take out a factor from the power that is even, and we want to make sure that that term will be positive. Now, if x is negative, it will make this entire term that we took out of a square root or an even root a negative, which means that this is going to need absolute value. So here we have the square root of x plus y. And you're probably wondering and probably thinking about that rule that stated that if we have x inside the radical, it protects the x outside from being negative because the condition is whatever is inside is positive. However, because x and y here are together, they're connected to each other by addition, there is a chance of x being negative, and with a bigger positive y value, they still exist. So to make sure that 5x stays positive, we will be needing the absolute value notation there. So let's continue with the next question, and I'm going to try to cut the way a little bit shorter. So the index is 2. So I'm going to draw the radical symbol here with index 2. And we're going to deal with every part of the term one at a time. So I have 16, which is 4 to the power 2. And I have a to the power 3, which we will have to break it down into a to the power of 2, a to the power of 1. Now, as you can see in here, some of the powers for a would be positive, some negative, and that's okay. That's the way it is in this expression. So what we'll do is combine the perfect powers of 2. And right here, we will have the square root of, we have 4a to the power of 2. And then we have a, and then a plus b. So whatever has, or whichever factor has a power of 2 can come out. So that means that, and I'm going to show the steps in here as well one more time. So that's 4a squared, index 2. And then we have the square root of a times a plus b. So 4a can come out. And inside here we'll have a squared plus ab. Now there is a chance of a being negative and making this expression, negative as well. So in order to make sure that this stays positive and also this stays positive, then we're going to have to use the absolute value in this case. And we'll have in here a squared plus ab. You can keep it either in factored form or expanded form. So in the next group of questions, we have to express as entire radicals. So we've done some exercises with expressing the answers as entire radicals, but we've dealt only with single terms. So here we have the product of two radical terms. To express as entire radicals, then we have to first multiply. Remember that we cannot multiply two radicals unless they have the same index. And in this case, we don't have that problem, so we can go ahead and multiply them. So we have 5b times 3a. So that would be equal to 15ab. So square root of 15ab. So next, we'll have to write this term as entire radical. As you can see here, we have an example of a mixed radical. So we have a regular term and a radical term. A regular term, so to speak, right? So 3xy squared. And then we have the square root of xy. So since the index is 2, it means that we want to bring this term inside a radical with index 2. And in order to make sure that the value of the term won't change, we're going to bring this to the power of 2 as well. So now we can combine the two radical terms. And we have an index of 2 here. And we can bring them together, but remember that the power of 2 will apply here to every term. So that means we have 3 squared, which is 9, x to the power 1 squared, which is x squared, and y squared to the power of 2 is y4, multiplied by x times y. So multiplied by x times y here. Now, it's the same multiplication. And now we have to express it as a single radical number or as an entire radical. So let me make this smaller. And this would equal 9 x to the power of 3, y to the power of 5. Remember, these are the powers here. And we have in here the square root of this entire expression here. Wait a second. There we go. And we're moving on to our next question. It's asking to simplify, which means that we have to perform whatever operation is present in the question. And then at the end, we have to write the answer with the smallest radicand possible. So let's get to work. So first we divide. Same index means that they can come inside, the terms can come inside the same radical. So what we have now is 9x to the power of 4. We'll simplify this. We know that 9 is a 3 to the power of 2. We know index is 2. And we also have x to the power of 4, which will be x squared to the power of 2. So the answer in this case would be the square root of 3x squared to the power of 2. You can definitely cut the way short. I'm only showing the different paths to simplifying it so that everyone can understand it. And the answer will be 3x squared. So these two will simplify. If you look at the final answer in here, notice that since we have an even radical, we have to ensure this will always be positive. And when you look at the variable part, to the power of 2, even power, will always be positive for any real number. Let's do the next one. So this time we have 200m7n squared divided by 10m to the power of 3. So that's a square root. We'll bring everything inside the same radical divided by 10m cubed. Now we have 200 divided by 10, which equals 20. We have m to the power of 7 divided by m to the power 3. That's m to the power 4, and then n is squared. All of it square rooted. So because we have an index of 2, then what we're going to do is break down the coefficient into two factors, and we want one of the factors to be a perfect power of 2 so that we can simplify. So 4 is a perfect square and is a factor of 20, so we'll break that down into 4. And then we have 5, and then m squared, m4, and n squared. So in the next step in here, we're going to have number 4, which is a 2 to the power of 2. And then times 5. And then times m to the power 4 can be m squared to the power of 2. And then lastly, we have the term n squared. It's already a perfect power. So whichever term has a power of 2 can come out of the square root or the radical with index 2. So what that means is that number 2 will come out, m squared will come out, and n will come out as well. So the powers will simplify. And what's left inside the radical would be simply the square root of 5. Now we have to make sure that all the terms that we have in here give a positive number, and or the product will be always a positive. Number 2 is a positive. M squared will be positive for any real number m, but n can be negative. So what we're going to do is put absolute values around n. And this will be the most simplified form of this question, of this expression. Okay, let's make this a little smaller so we have room for our next question. So this time we're simplifying. And when we simplify, we want to take out as many terms as possible from here, which means that 5xy is very happy where it is, outside. And now, since we have an index of 2, we'll write number 8 as a factor or a product of two factors, one of them perfect squares. So it seems that we have a factor of 4 and 2. And then we have x to the 20, so we're going to write x to the 20 with the power of 2, which means we're going to need a 10 in here. And y7, we're going to break the power 7 down into one even power and y to the power of 1. Now, if you're wondering why do we need the even power, the reason why is because, let's make this perfect. So we need this in even power because even powers can simplify the index. So continue the next step, 5xy will stay where it is. And we're going to look at the perfect terms, perfect powers of 2 terms. So we'll have in here number 4, which is 2 squared. So this is done. It's a perfect power. X to the power of 10 squared, that's a perfect power as well. And we have y to the power of 6. And y to the power 6 will be a perfect square as well, with y to the power 3 as a base. And then we have y to the power of 1 here. So everything that is in the base of a perfect power can come outside of the root. So we have 5xy, and then multiplied by 2 is coming out, x to the 10 is coming out, y to the power 3 is coming out. And inside the root, we'll have simply the variable y, and we almost forgot this number 2 here at the very end. So the number 2 is not part of the perfect squares in here. So y times 2, or 2y. So as you can see in here, I'm going to write it as 2y because it looks nicer and makes more sense. Okay, so as you can see in here, we took out an x to the power of 10, which will be positive for any real number x, which means that this will be safe to sit here without radical symbol, absolute value symbol, so we don't need to make it positive. And then we have y to the power of 3. Now, this is an odd power, so if y is negative, this is at risk of becoming negative. So this can become negative. So we cannot take negative numbers out of the even roots. But wait a second. As you can see here, we have y to the power 1 here. So this is that case that says that, oh, this y inside the radical guarantees that y will stay positive. So this y here is safe to be out there with no radicals, with no absolute values. Okay, so now all we have to do is combine all these terms together, and then we have a 5, a 2, make a 10. We have x to the power 1 with x to the 10, that's x11. And we have y to the power 1 and y to the power 3, a y to the power of 4. And inside we'll have the square root of 2y. So we'll continue with the rest of the questions in the next video. I hope this helps you better understand absolute values and radicals and how they're connected to each other. And keep learning. Thank you for learning with me. Bye.